And to do that for every single model, for every single feature was a pain. And we did it wrong so many times before we got it right. So we knew this wasn't the right way to go. And our solution to this was developing a machine learning feature store where we wanted to have essentially a one-stop shop for all machine learning data. And we realized that we were essentially serving two use cases here. One is this kind of bulk training use case where we wanted data to be made available for all of our users that use the SurveyMonkey platform, but still in an easy enough way that maps to the use case of our machine learning projects. So I gave a talk about actually our machine learning feature store at the O'Reilly Strata Data Conference last month. And I can show like a quick slide maybe so that it makes a bit more sense of
Yeah, great.
what this kind of looks like.
And that's something that I remember when we talked last. You were telling me, yeah, we're almost done with the feature store.
Cool. So the way that we thought about this ML feature store was actually I'll show a different slide first. We took a good hard look at our data patterns that existed within our organization, and we found a relationship that we had several one-to-many or one-to-one relationships that existed between our data and the entities between them. And then we also realized that our data scientists wanted point-in-time window views into our data as well. So let me break down what that means. So if I'm say like Airbnb, I might be developing machine learning models that are centered around our guests or our hosts. And these entities have all their relevant feature data about them. But then they might have some more in-depth data about, say, a guest can have many stays, a host can have many homes. And these one-to-many relationships are then aggregated in view with respect to a certain entity. And so at the end of the day, what data scientists really want is a super flat table that contains all the information about that entity and all aggregated else other information about their sub entities or higher level entities. And they're at the end of the day, they also want this information with respect to a certain time. So how did that data look like for a certain user on January 1st, 2016? I should be able to know that so that I can develop, say, like a conversion model or a churn model about this. And so we thought, okay, we really need to have a feature store that serves this use case for our training purposes. And ultimately, the structure that we were able to come up with that was super simple for our data scientists to use and work with and easy for us to develop enough was creating a flat table for each entity where we have each entity ID broken down by each day. So each day's data and then all the features specific to that entity. I know this is like a really wide flat table, it has hundreds of features. And this made it super easy for our data scientists to get up and running with any use case that they needed to work on. And so this machine learning feature store sits within we use AWS for all of this. So we leverage EMR to do a lot of our data processing. We leverage AWS Athena as our final tables for entity tables for our data scientists to send requests to. And it's backed by S3. So all the data is actually just sitting in S3 for us. And it's really exciting to see that work in real life. And then from there, we had, so that's really our batch use case. But then I talked about like our serving issues, right? So at the same time, we have a streaming architecture that reads off of our application logs from all of our services and creates a one-to-one mapping between the features that are in our feature store here and what spills off of our application logs. In real time, these values are then updated in a similar exact same structure feature store that can be read in, at a single layer, at a single line. So if I want to know what is the data for a specific entity on a specific date, I hit my real-time feature store for that, and my services hit that real-time feature store, and the latency on that is, just a few milliseconds. And so really, I'm able to get single line reads super fast from my real-time feature store, but I'm able to do my bulk reads against my bulk feature store as a data scientist whenever I want, again, at a pretty fast speed. So I know that was a lot of information. So I can maybe take a quick pause for you to ask some questions there.
That was great.